We have been learning a lot about parallel lines, triangles and parallelogram, and we know certain properties of them. But have you ever wondered what will happen if we will combine triangles with parallel lines or parallelogram with parallel lines? So let's start this session by juggling with these shapes and figuring out certain very simple and yet very important properties. Here you can see a road, and on both the sides of the road there are street lights. So using this situation, let's see what we can come up with. Consider there are two poles on both the sides of this road, and let's draw two triangles by joining these poles. So by looking at the diagram, can you tell me what is common between the two triangles? They have a common base, and one more thing is common between them. They also have a common height, because if we see the boundary of the road, they form parallel lines, and we know the distance between two parallel lines is always constant. Therefore, height and base is same for these triangles. So, when we calculate the area, we use a formula half into base into height. Now, since the base and the height of both the triangles is same, the area of the triangles is also going to be the same. So from this we can conclude, when two triangles are drawn between the same parallel lines and having the same base, their areas are also going to be equal. Let's try some other combination of triangles and see what we can learn through it. Now consider one light pole on one side and three light poles on other side of the road. Again we have two triangles. Now, can you tell me what is common in both of these triangles in terms of base and height? We can see the height of both the triangles is same because they lie between the same parallel lines. But what can we say about the base? Here we can see that the bases are different. If we notice the diagram, we can clearly see that we have split one big triangle into two by joining a line. Even if we didn't have the parallel lines, we can still say that both the triangles have the same height. So the conclusion is, if we draw two triangles by splitting one big triangle, the height of all the three triangles is going to be the same. And when we find the areas of these triangles, their areas will not be equal. But the ratio of their areas will be equal to the ratio of their bases. Because when we take the ratio of areas, the constant value half and the height will get cancelled out, and the remaining thing will be the ratio of the bases. Here we spoke about the bases, but suppose the bases were equal and the triangles are still between the same parallel lines with equal areas. So now, what can you say about the height of these triangles? I have already given you a hint. The height of both the triangles will be same. So what does this imply? It says that triangles with equal bases and equal area will have equal height, or we can say that they lie between the same parallel lines. Here we are done with properties of triangles. Let's do a small recap before we move to the property of parallelogram. Here we move to one and the last property of this session based on parallelogram. Now if we look at the same street lights arrangement, we can make a parallelogram out of it. Now suppose if we add two more street lights on the top, then we can see that we have two different parallelograms but with the same base. So can you think of something of the area of these parallelograms? We know the formula to calculate the area of parallelogram is base into height. We know the base of both the parallelograms is same. But then what about the height of these parallelograms? Let's draw perpendicular heights for both the parallelograms, and what we can see now? Aren't the heights same? Yes, they are. So from this we can say that the area of both the parallelograms is equal, or we can say that the parallelograms on the same base and between the same parallel lines are equal in area. Wasn't this session interesting? We have learnt few important properties about triangles and parallelogram. But where are we going to use these properties? Let's have a look at one problem which we will solve using these properties. In the given figure, PQRST is a pentagon. A line through Q parallel to PR meets SR produced at U. We have to show that area of triangle PQR is equal to area of triangle PUR, and area of quadrilateral PTSU is equal to area of pentagon PQRST. Before we start, let's name the point of intersection of PU and QR as Y. Friends, if you look at the question have words like areas of triangles and parallel lines. So by looking at these keywords, you can directly say that the problem is based on areas of parallelogram and triangle chapter. Now we have to prove that area of triangle PQR is equal to area of triangle PUR. Next thing is, you don't have to be afraid by looking at the diagram. Let's just try to simplify the diagram and concentrate on the part we are given and we need to prove first. So the most important part in such questions is to find out the parallel lines, which are PR and QU. If we look closely, both the triangles also lie between the same parallel lines and they have a common base, that is PR. So now can you tell me using which property we can say that the triangles have equal areas? Yes, you're right, using property 1. Now we can say that area of triangle PQR is equal to area of triangle PUR. Here we are done with the first part of the solution. The next part says that we have to prove that the pentagon and the quadrilateral are having equal areas. Now the second part may look complicated, but you will see how we can easily solve it using the first part itself. Here we can split the quadrilateral into quadrilateral PTSR and triangle PRU, and in the same way we can split the pentagon into quadrilateral PTSR and PRQ. And as we have already proved that both the triangles have same area, so from 1, 2 and 3 we can say that the quadrilateral and the pentagon will also have equal area.